Hey kids, welcome to section 1.4, writing linear equations. Today we're going to learn how to write an equation of a line given the slope and a point on the line, and also how to write an equation of a line parallel or perpendicular to a given line. So there are lots of different forms of equations. Specifically, we're going to talk first about the slope-intercept form of an equation. Slope-intercept form of an equation, y equals mx plus b. I'm sure you've heard it before. The m is your slope, the b is your y-intercept, and in case you need a visual, the y-intercept is the place where the line crosses the y-axis. There are also x-intercepts that we will talk about at some point, but not right now. So the y-intercept, the place where the line crosses the y-axis, it's a point, which means it has an x and a y. Since it's on the y-axis, the x value is 0. That's why the intercept is 0, b. And then your slope is m. It's how much it rises over how much it runs. So the directions are going to say write an equation in slope-intercept form for the line described. So I'm going to write y equals mx plus b at the top here, so we just have a visual of what slope-intercept form is. The slope is 4/3 and the line passes through the point 0, 4. Well, if your slope is 4/3, that's your m. If it passes through the point 0, 4, then that's your x and your y. So in your equation, you have the y, you have the m, you have the x, you need the b. So we're going to say y equals 4 equals m, which is 4/3, times x, which is 0, plus b. Well, 4 equals, when you do 4/3 times 0, you get 0. That means your b is 4. You're not done. Write your equation. Y equals m, which is 4/3, leave your x alone, plus b, which is 4. So when you write your final answer, you're going to plug the m back in and you're going to plug the b back in, but you're going to leave the x and y alone. Okay, letter B passes through the point 0, -6 and -4, 10. Well, kids, I need a slope. So let's calculate slope first. So take y2, 10, minus y1, -6, over x2, -4, minus x1, 0. That gives me 16 on top, -4 on the bottom, gives me a slope of -4. Now we need to figure out what our b is. Well, we need to use one of these 2 points. It doesn't matter which one you use. I'm going to choose the first one because one of the numbers is a 0 and it's easy to plug in. So I'm going to go back to this y equals mx plus b equation and this time plug in the -4. So I'm going to get -6y equals m -4 times x 0 plus b. So -6 equals, well, this gives me 0. So b is -6. Don't forget, you got to write your equation. Y equals m, which is -4, x plus, or in this case, -6. Okay, so I said that slope-intercept form is one way to write an equation. Another way to write the equation is something called point-slope form. Point-slope form looks like this. Y minus y1 equals m times the quantity x minus x1. It's basically the slope formula rearranged. Notice if you were to divide by this x chunk over here and put it on the other side, then you'd have y's on top and x's on the bottom, and that's the slope. So it's a different way to write equations of lines other than the way we just wrote them. So in these, we want to write an equation in point-slope form for the line described and then transform the equation into slope-intercept form. So passes through 2, 3, and the slope is 1/2. So this is like our x and our y. So remember, your point-slope form is y minus y1 equals m times the quantity x minus x1. Put that at the top here. So this is really x1, y1. when we're using the point slope form. You're going to always leave the regular x and y alone. So if we use that equation up there, we're going to do y minus y1, which is 3, equals m, which is 1/2, times the quantity, leave the x alone, and substitute in 2, so x minus 2. This is considered point slope form. Doesn't really do much, so that's why one of the parts of the directions is to transform the equation into slope-intercept form. Well, slope-intercept form is y equals mx plus b. So now we have to get what we just wrote to look like slope-intercept form. Well, to do that, I'm going to have to distribute this fraction. So let's multiply the right-hand side. Y minus 3 equals 1/2 x, and 1/2 times -2 is -1. And then the only other thing I have to do to get the y alone is to add 3 to both sides. So you get y equals 1/2 x plus 2. So we have taken a situation where we know the point and the slope, and we have substituted it into point slope form and transformed it into slope intercept form. All right, letter B passes through the point -2, -1, and the slope is -3. Well, let's think of this as x1, y1, and so we're going to do y minus a -1 equals m, which is -3, and x minus a -2. That can get really ugly, so you might want to just in the very first step do y plus 1 equals -3 times x plus 2. Your choice how your brain thinks about it. In any regards, we're going to have to distribute on the right hand side, so y plus 1 equals -3x minus 6. And then we need to subtract 1 to both sides, so we can get y equals -3x minus 7. Alright, let's kick it up a notch and do some interesting ones. Write an equation in slope-intercept form of the line passing through each pair of points. Now I've taught you two different ways that you can find it in slope-intercept. You can either right away do slope-intercept form, but that can get a little jumbled, or you can first start in point-slope form and then translate it to slope-intercept. I think it's a lot easier to start with point-slope, so that's how I'm going to do it. Okay, letter A. So they've only given us 2 points, so the first thing I need to do is find the slope. So first I'm going to find slope by doing -4 minus a -9 over 2 minus 4. That's going to give me 5 over -2, so my slope is -5/2. Then I'm going to pick one of these points. It really doesn't matter which one. I'm going to pick this one because it's got smaller numbers. And I'm going to use my point slope form now to do y minus a -4 or y plus 4 equals my slope, -5/2, times x minus my 2. Now I need to distribute the -5/2, so y plus 4 equals -5/2 x. If I do -5/2 times -2, that gives me 10 over 2, which is 5, and then minus 4. If you're not good at doing fractions in your head, grab your calculator, kids. There is no shame. -5/2 x. I don't know why I put a 5 there. That should have been a 4 right there. Because you get plus 1. -5/2 x plus 1. Alright, letter B, -2, 0, and 1, 5. First I need to find the slope. So I'm going to do 5 minus 0 over 1 minus a -2. That gives me 5 over 3, so my slope is 5/3. I'm going to pick one of the ordered pairs. I'm going to pick the first one with the 0, and I'm going to do y minus y1, which is 0, equals m 5/3 times x minus x1, which is a -2, so that becomes a +2. I'm going to distribute on the right side, and notice the left side is just y. So we get y equals 5/3 x plus, and if I multiply 10/3. So that one's really nice because one side simplifies quite easily and you don't have as many steps. Okay, letter C, -3, -1, and 2, -1. Let's find the slope. So I'm going to do -1 minus a -1, and then do 2 minus a -3. That leaves me with 0 over 5, which is 0. Now, when you come across one where the slope is not a normal number, then you're either dealing with a vertical line or a horizontal line. So if your slope is 0, you are dealing with a horizontal line. So think about -3, -1, and think about 2, -1. The slope is 0. Well, when you have a line that has a slope of 0, it's a horizontal line, and it goes through the y-axis. So the equation is going to be a y equals equation. Now, let's back up a step and let's just use the point slope form, and I'll show you something weird that happens. So if I choose, let's say the second point, and do y minus a -1 equals 2, or equals m, which is 0 times x minus 2. Then the left side is y plus 1. And on the right side, anytime I multiply anything by 0, I just get 0. 0x and 0. And then bring the 1 over, y equals -1. Now kids, notice over here on the picture, this horizontal line that we drew is going side to side through the y-axis at -1. And guess what? The equation is y equals -1. And guess what? Both of the y values were -1. Ooh. Okay, letter D, 6, -2, and 6, 5. So let's do slope as 5 minus a -2 over 6 minus 6. That gives us 7 over 0. Ooh, that's an undefined slope. Undefined. So if you draw a picture, 6, -2 is like right here, and 6, 5 is like right here. Well, that's a vertical line. Vertical lines have no slope. They're undefined. Vertical lines go through the x-axis. Well, if you go to try to do the formula, y minus, and let's choose, I don't know, the 6, 5 point. If I do y minus 5 equals, and then how do you plug undefined in for a slope and then do x minus 6? It's really not possible. So keep in mind that it's going through the x-axis and it's going through x at 6. So your equation is x equals 6. Every vertical line is going to be x equals, and then whatever the number is. Also notice that both of the x values were 6's. Okay, let's talk about parallel and perpendicular lines. Slopes can help you determine whether two lines are parallel or perpendicular. Parallel lines are two lines that never meet, and if the two lines never meet, then they have the same slope. They're both going up at the same amount or decreasing at the same amount. If instead you have perpendicular lines, those are lines that form a right angle. When those lines form a right angle, their product is -1. That means one of them is positive, one of them is negative, and if I multiply them together, I get a -1. It's kind of weird. So if you have 3, you have -1/3. I think of these as opposite reciprocals. It's the opposite number, and it's the reciprocal of the number. That means you flip it as a fraction. So for instance, the slope before was 3 over 1. If you make it negative and flip it, it becomes -1 over 3. Parallel lines have the same slope. That's why the 2 is the same as the 2. So let's write some equations for parallel and perpendicular lines. Write an equation in slope-intercept form for the line described. So remember, you can start with point slope, or you can go right to mx plus b like we did in one of the very first examples. Okay, so passes through the point 3, 7 and is parallel to 3/4 x minus 5. Okay, well, if it's parallel, that means it has the same slope. So if the slope of this line is 3/4, then the parallel slope is also going to be 3/4. So that's our m, and this is our x1, y1. And so we can go straight to writing the point slope form. We can do y minus y1, which is 7, equals m, which is 3/4, times x minus x1, which is 3. Distribute the 3/4, so y minus 7 equals 3/4 x minus 9/4, because you can put a 1 underneath the 3. And then add 7 to both sides. Y equals 3/4 x, and if you do negative 9/4 plus 7, you get 19/4. Notice that the equation of that line, 3/4, is the same as the slope of the original equation, 3/4, and that's because they were parallel. This time in letter B, it passes through the point 5, negative 6, and this time it's perpendicular to 3x plus 2y equals 7. Well, if it's perpendicular, that means I have to do opposite reciprocal slope. Well, I don't know what the slope is yet because it's not written in slope-intercept form. So I need to make it be y equals so that I can pick the slope out. So I need to subtract 3x to the right-hand side, actually both sides. So 2y equals negative 3x plus 7. We need to divide everything by 2. So y equals negative 3/2 x plus 7/2. Now the slope of this line is negative 3/2. The perpendicular slope is going to be the opposite sign, which is positive, and you flip the fraction to do 2/3. So opposite sign, reciprocal number. Now I can take this information and use the x1, y1 to write my point slope form. So y minus a negative 6, so y plus 6, equals my m 2/3 times x minus x1, which is 5. Distribute the 2/3, y plus 6 equals 2/3 x minus, if you think of this as over 1, you get 10/3. Add 6 to both sides. Y equals 2/3 x minus 28/3. Notice the slope of this line is positive 2/3, and the slope of the original line is negative 3/2, opposite reciprocals. All right, kids, that is the end of section 1.4. If you have any questions, please let me know, and as always, keep calm and keep trucking.